Good morning, students. Today's lecture focuses on the lactoperoxidase system, commonly referred to as the LPS system, in milk preservation. This is a scientifically approved natural antimicrobial system that extends the shelf life of raw milk, especially in areas where refrigeration is not immediately available. In this session, we will examine its components, mechanism of action, activation requirements, advantages, and limitations. Let us begin with the introduction to the lactoperoxidase system. As shown on this slide, it is a natural antimicrobial defense mechanism. It is naturally present in bovine and buffalo milk. It is also recognized as an alternative preservation method, particularly when refrigeration is not available. Importantly, it can extend shelf life for approximately 7 to 8 hours at 30 degrees Celsius, allowing safe transport under tropical conditions. Thus, it is both safe and natural. The system consists of three essential components. First, lactoperoxidase enzyme. This enzyme is naturally present in milk. Second, hydrogen peroxide, H2O2. This acts as an oxidizing agent and activator. Third, thiocyanate ion, SCN-. This is the substrate upon which the enzyme acts. Only when all three components are present in proper proportion does the system become active. Now let us examine the lactoperoxidase enzyme. It is naturally abundant in bovine and buffalo milk. Its primary role is catalytic. It catalyzes the oxidation of thiocyanate. The enzyme is stable at low hydrogen peroxide concentrations. The diagram here shows the molecular structure and active site interaction during catalysis. This enzyme initiates the antimicrobial reaction. Hydrogen peroxide plays a critical role. It acts as an essential activator. It serves as the oxidizing agent, providing oxygen for the reaction. The concentration must be carefully controlled, typically around 10 to 14 ppm. If added in excess, it can destroy the enzyme rather than activating it. Thus, precise dosage is mandatory. The thiocyanate ion is the primary substrate. It is naturally present in milk, though levels vary depending on cattle feed. Supplementation ensures adequate concentration, usually 10 to 15 ppm. During the reaction, thiocyanate is oxidized to form hypothiocyanate ion, OSCN-. This is the actual antimicrobial ion. Let us understand the mechanism of antimicrobial action. The sequence begins with lactoperoxidase. Hydrogen peroxide activates the enzyme. Thiocyanate is oxidized, forming OSCN-, the antimicrobial ion. OSCN- oxidizes sulfhydryl groups, also called SH groups in bacterial enzymes. This leads to enzyme inactivation and metabolic disruption. Thus, bacterial growth is inhibited. Certain conditions are required for activation. First, raw milk quality must be good. The system cannot restore spoiled milk. Second, optimal pH. The system works effectively between pH 6.5 and 6.8. Third, correct ratio of SCN and H2O2. Both should be approximately 10 to 14 ppm each. Fourth, timely activation. The system must be activated within 2 to 3 hours of milking. These parameters ensure effective preservation. The effect on microbial growth include both bacteriostatic and bactericidal actions. The bacteriostatic effect inhibits multiplication of mesophilic bacteria such as lactococci. The bactericidal action targets gram-negative bacteria like E. coli, Salmonella, and Pseudomonas. As shown in the illustration, microbial growth is significantly delayed. Shelf life is extended for 7 to 8 hours at 30 degrees Celsius without masking poor initial quality. The advantages of the lactoperoxidase system are significant. It is a natural preservation method utilizing enzymes already present in milk. It is cost-effective, especially in remote collection centers. It enables milk collection from areas lacking cold chain infrastructure. It is approved by FAO and WHO as a safe method for temporary raw milk preservation. However, limitations must be clearly understood. The system requires good initial milk quality. It provides only temporary preservation. It is not a permanent substitute for refrigeration. Milk treated with LPS must still undergo pasteurization. Strict dosage control is essential. Improper ratio can be ineffective or unsafe. Therefore, careful supervision is required. application in milk collection and transportation follows a structured sequence. At farm level, SCN- and H2O2 are added within 2 to 3 hours of milking. At collection center, milk is aggregated without immediate chilling. During transportation, shelf life is extended for 7 to 8 hours at 30 degrees Celsius. At the processing plant, pasteurization destroys microbial cells and residual activity. Thus, the system bridges the gap between milking and processing. This visual summary consolidates the process. Input components: lactoperoxidase, thiocyanate ion, and hydrogen peroxide. Reaction: enzymatic oxidation of thiocyanate. Mechanism: formation of OSCN-, which oxidizes bacterial SH groups. Result: milk preservation with extended shelf life in tropical conditions. To conclude, the lactoperoxidase system is a scientifically validated, temporary milk preservation method. It is especially valuable in regions lacking refrigeration facilities. However, it must never replace proper refrigeration and pasteurization. As dairy technologists, you must understand both its benefits and its boundaries.